Hello, this is Michael DeLay from IDEX Health and Science Semrock. I'm here to introduce the Avant filter set family. Each member of this new family maximizes the fluorescence performance from a corresponding short Stokes shift fluorophore. To do so, I'll tell you a bit about the rationale and the challenge, give you some idea of the product and design targets and the key tools and technology that were used, some results, and then a little bit of information on rollout. We start with the Stokes shift. That's the separation between peak excitation and emission wavelengths for a probe. Some of the most popular probes have quite small shifts, less than 3% of the wavelength range. It is the case that for many of these small Stokes shift probes that the gap between the proximate edges, excitation to emission, as shown here, is placed asymmetrically with respect to the crossover point. That means that the emitter filter is shifted to longer wavelengths. This reduces the amount of light that is captured by the emission filter and reduces the filter set performance as a whole. So the question is, can one reduce this gap? The difficulties involved are that one has increased excitation bleed through due to excitation light reflected into the emission channel, and the fact that this narrow range of wavelengths can be tricky to place filter edges very precisely, and there's a possibility of collision between the filters at deeper ODs. Fortunately, the Avant fluorescent filter sets have been engineered to improve the probe performance by reduction of this gap. This was achieved in 3 separate steps. First, the proximate edges of the 2 excitation and emission bands were steepened, very significantly steepened. Once they were steepened, then the gap could be reduced, namely by moving the edges closer together. And then finally, the complementary blocking was introduced into both filters in order to reduce excitation light bleed through. Semrock is uniquely positioned to deliver these kinds of filter sets because of some proprietary capabilities. The first is advanced optical coating performance process control. This results in steep spectral edges. It allows us, in other words, to coat very steep spectral edges and locate them precisely. And that precision of placement is achieved by a tightened statistical distribution of edge positions called precise edge placement. Thirdly, the Kohler deep spectral measurement system, which resolves very steep edges and deep ODs, can be used to verify the actual performance of the filters once coated. Modeling was performed using the Semrock Searchlight simulation tool. Here's an example of a probe, the Venus probe with a particular excitation source. We compare the Brightline catalog filter set to the Avant filter set and see an increase in the fluorescence, shown here in %, and over here it indicates that the excitation light bleed through is now essentially eliminated. In order to see what it looks like, this is an example for Psi 5.5 and shows this yellow band of increase. Customer evaluations indicate that there's something like 40% increase of signal over background in the experiments that they performed. The rollout is now in process. 4 sets have been released and 4 more sets are on the way. And for further information and a chance to look at those sets, please contact our distributor for universities and government labs, AVR Optics. Thanks for your attention.